8, one of the more challenging sections at this point, rate, time, distance problems. These are the types of word problems that give 8th graders fits. They tend to be the main reason why students aren't able to test out of Algebra 1, no matter what high school you go to or are taking a placement test. Marymount, Notre Dame Academy, Notre Dame High School, Loyola, Bishop Montgomery. Those are pretty much the schools that give placement tests. But we have rate, time, distance problems. So we know that distance equals rate times time. And we're going to utilize that knowledge, that fact, when we see this problem. If we look at it, 2 jets leave St. Louis at 8 a.m., one flying east at a speed of 40 kilometers per hour greater than the other, which is traveling west. At 10 a.m., the planes are 2,480 kilometers apart. Find their speeds. So you can get really overwhelmed with that. I'm going to teach you some methods to help with that, where we're going to understand the problem. We're going to do a little bit of drawing. 2 jets leave Ontario at the same time, one flying east, one flying west. So we always want to read the problem first. So here we have Ontario. One is flying west. Yes, that's the western direction. The other flying east. So they start at the same place. This is going to be distance equals rate times time. This is going to be distance equals rate times time. And we have this situation. So what information can we put in there? So one flying east at a speed of 20 kilometers greater than the other. So that's flying speed is a rate. So I don't know the west rate of speed, so we'll give it R. Let's keep it simple, R. And we know that the one going east is going faster, 20 kilometers faster. So these are the rate of speeds for each of the planes. So we got one of the variables down. We got that. That's pretty good. And then it says, after 4 hours, the planes are 6,000 kilometers apart. So we now just figured, well, let's do this. This is the speed, which is flying at a speed, so we know that. Now we're given time, 4 hours. And what do we know about the time? The time is the same, because they start at the same time, and they're going to fly for 4 hours. So I'm going to put 4. We can put it for T, 4. I'm going to put T, 4, and we're going to put 4 in for T for both of those equations. So here's the interesting part. So this is the distance for the plane going west. This is the distance for the plane going east. Now, I don't know how far they're going west. I don't know how far he's going east, but I know that after 4 hours, that total distance between them is going to be 6,000 kilometers. I know this distance is going to be 6,000 kilometers. And so, right, this is the distance from the start to there. This is the distance from start to there. So I know if I add these two distances, it should equal the total distance. So I've now created an equation. 6,000, which is the total, equals the sum of the parts. R times 4, I'm going to make that 4R. And then it's going to be plus 4 times the quantity R plus 20. And now it's a relatively easy basic equation that we can solve for. 6,000 equals 4R. We're going to distribute that. That equals 4R plus 80. Let's simplify the right side first. So that's 8R plus 80. Now let's isolate for the variable. Let's subtract 80. Not a lot. 5,920 equals 8R. Let's divide both sides by 8. I'm not going to do that in my head. I'm going to use my handy dandy notebook, right? Anybody remember Blue's Clues? 740. 740 equals R. So what does that mean? R was the rate of speed. Well, was it the rate of speed for both of the planes? No. We see that the west got the R and the east got the R plus 20. So the plane going west was traveling at 740 kilometers per hour. The plane going east was going 20 kilometers per hour faster. So that was going 760 kilometers per hour. But that may not answer the question. It says find their speeds. So I did plane going east 740, plane going west 740, plane going east 760. Sound good? Good. New problem. 2 camper vans leave Arrowhead Lake. I mean, did they write this? Did the book people, are they from California? Because it feels like they're from California. Ontario, California. Arrowhead Lake, California. 2 camper vans leave Arrowhead Lake. We'll just, AL does not stand for Alabama. It does not stand for American League. It stands for Arrowhead Lake. At the same time, one traveling north. Well, we'll make this go north. I know north isn't right. North is up, but we're going to just keep it that way. And the other one going south. So we have, again, distance equals rate times time. Distance equals rate times time. The rate of speed, so the camper, same one traveling north, 10 kilometers faster than the other. So this is going to be R. The north is going to be R plus 10. That is the rate of speed. I think we made that green. Traveling north, that is faster than the other. So north is traveling 10 faster speed. I don't know how fast the south is. After 3 hours, so I know my time. That's nice. That's typically not given to you, but in these first 2 examples, it's nice that we know what the time is. We know that they're going to travel for 3 hours. The camper vans are 420 kilometers apart. So we again know what the distance from the starting point to after 3 hours. So after 3 hours, that camper is going to be in that location. After 3 hours, that camper is going to be in that place. And that total distance is going to be 420 kilometers. So that's how I'm utilizing this. I don't know the specifics, but I know the generalities. I just made that word up. So let's add the 2 distances, RT, oh, sorry, not RT, excuse me, 3R. Well, let's do 420 equals the distance going south, which is 3R, plus the distance going north, which is 3 times the quantity R plus 10. 420 equals 3R plus 3R plus 30. 420 equals 6R plus 30. Let's subtract the 30. You get 390 equals 6R. Divide by 6, divide by 6. Is that going to go nicely? Are you going to play nice? Divided by 6. Oh, you are going to play nice. 65 equals R. So remember, what is R? R is the speed of the south. And so going north is going to be 65 plus 10, or 75. So it says find their speeds. The camper going south is 65 kilometers per hour. The camper going north is going to be 75 kilometers per hour. I think that's within the speed limit. I think that is within the, what would we call it? Within the within the requirements of the camper in your signed agreement that you're not going to drive too fast. Two cars traveled in opposite directions from the same starting point. We've seen that. Here's our starting point. Cars are traveling in opposite directions. The rate of one car was 10 kilometers less than the rate of the other. I don't know which one is which, but we got one car going in this direction. We're going to call this car 1, and we'll call this car 2. And distance equals rate times time is always going to be how we find that. One of the cars is going to be R, and the other car is going to be R minus 10 this time. So less than the rate of one car is 10 minus 10 less than the other. So we're okay with that. And then after 4 hours, so same similar thing, after 4 hours, so we know what our time is. Our time is going to be 4. We'll put 4 in there. So rate times 4 times time times 4, which is our time. And then we know after that time, they're going to be 600 kilometers apart from each other. And once we do, what number is this? Our third one? Our third one, we now see a lot of similarities. We see how we're setting this up. We see the simplicity is the total distance equals the sum of the parts. That's car 1 distance. This is car 2 distance. The only difference we have to make sure is what are the speeds, how they related to each other. 600 equals 4R plus 4R minus 40 this time. Let's simplify the right side. That gives us 8R minus 40. Now let's isolate and solve for the variable. 640 equals 8R, divide by 8. That's going to give us 80 is the rate of speed for car 1. One car is going 80 kilometers per hour. Now I find it very interesting if we're in California, why are we dealing with kilometers per hour? And then the other car, nobody in California deals with the metric system. The other car is going 10 miles per hour slower, so 70 kilometers per hour. And there are no traffic signs with kilometers. Find the rate of each car. We're good. That's the rate of speed. Here we are back to our plane again. A small plane leaves an airport and flies north. A jet leaves an airport 30 minutes later and follows the same plane at 360 miles per hour. How long does it take the jet to overtake the small plane? This is fun. This is where I kind of wish I had human beings, that we had a video, because then you can see how this works. If Jeffrey is standing right here and he leaves an hour, he leaves and then I leave an hour later, it says when does the jet overtake the small plane? So you're the small plane, I'm the jet. When I overtake, what do we notice? Our distances are the same. So they want to know when are our distances the same. And we still fill in for distance, rate, and time. So it's not much harder. It's just you have to understand the problem. A car started out in Memphis. That sounds like a song. Towards Little Rock, Arkansas. A second car left from the same point 2 hours later and drove along the same route. So car 1, it's going to be distance equals rate times time. At the rate of 60 kilometers per hour. And that's its rate. And we don't know how much time. We just know that it's t. So this is the distance of that car. Car 2 is distance equals rate times time. Car 2 is going to, second car left from the same point 2 hours later. So how long, and it drove 75 kilometers per hour. So this is 75 kilometers. And this is how we're going to set this up. So the clock starts ticking. And this car is going to start 2 hours after. So it's 2 hours less than, I can't believe it did it this way. Somebody's going home and you get to be on the video. Hello. I do. I will send her along. You're welcome. Bye-bye. Okay, video. This is here. So it's going along. You've got this car 1. So this is T. And then this car is driving along, but it had to wait. So even though the clock is ticking, it's not going to be this total time. If T was 4, what would this T be? Well, it would be 4 minus 2, right? So that's why we're going to do T minus 2. So that's the logic behind why we subtract 2, because it's not going to travel the same amount of time as car 1. But what do we know when a car catches up? Their distances are going to be the same. So we're waiting until their distance. So we're going to set these equal. It wants to know, when does the distance of car 1 equal the distance of car 2? Distance of car 1 is going to be 60t. The distance of car 2 is going to be 75 times the quantity t minus 2. As easy as that. Let's simplify. 75t minus 150. Let's subtract 75t. This is a little bit tricky here. You're going to get negative 15t equals negative 150. Enjoy, have fun. Auf Wiedersehen. Au revoir. Adama. And we get time. T. Am I solving for t? Oh, I am solving for t. T is 10. So what does t equals 10? T is for car 1. How long did it take the second car to overtake the first? And so I know that car 1 is going to drive for 10, how many? 10 hours. And I know that car 2 is going to drive for 10 hours minus 2. So for 8 hours. After that time, car 2 will catch up to car 1. That's how it works. Pretty neat. And make sure you got to read the question. What am I answering? How long? So my answer better be in time. So it took me 8 hours for the car to drive. It drives for 8 hours. Okay. A tourist bus leaves Richmond at 1 p.m. Richmond, Virginia, and it's going to start spreading the news. New York City, baby. So this is a bus. Distance equals rate times time. Later on, a truck is going to follow in the same path, the same direction from the same Richmond, Virginia. The tourist bus moves at a steady 60 kilometers. The truck travels at 80 kilometers. So distance equals rate time. So the truck is 80. That's its rate of speed, 80. The tourist bus travels at 60 kilometers per hour. And how long does it take? Oh, look at this. Exactly 24 minutes later. Have we noticed something? Did you notice a little place where they're going to try to trick you? Your speed is in hours. Your time that they gave you was in minutes. So when we plug in for time, we can't plug in minutes. Because our rate is in hours per hour, we have to convert our time to hour. So off to the little side here, we have to wonder how many minutes, 24 minutes, 24 minutes is equal to how many hours? Well, we know that 24 minutes out of 60. So that can be 12 over 30. That's going to be 4 over 10. That's going to be 2/5. 24 minutes on a clock is going to be 2/5 of an hour. 2/5 of an hour. Okay, so that's how we find out. So later the truck. So my bus's time is going to be t, and my truck's time is going to be t minus 2/5, because it doesn't travel the same amount of time. And we want to know, when does the truck catch up to the bus? So, let's grab this. Let's group it. Let's make it a little bit smaller. And let's make it nice and colorful. Hey, keep in mind, you have to convert minutes to hours. So they want to know, when are the distances, when is the truck going to catch up to the bus? So that means, when does the distance of the truck or bus equal the distance of the truck? This is distance of truck, this is distance of bus. So bus is 60t, truck is 80 times the quantity t minus 2/5. 60t equals 80t minus, 5 goes into 80 16 times. 16 times -2 is -32. We are going to subtract 80t, subtract 80t. That gives us -20t equals -32. Divide by -20, divide by -20, and we are going to get t equals 32 over 20, which reduces to 16 over 10, which reduces to 8/5. So t equals 8/5. Time is in hours. So we can either say 8/5 of an hour, or we can say 1 3/5 of an hour. And how much is 3/5? A fifth is 20. So that's, no, not 20, 10, no. 3/5 times 60. That's going to be 36 minutes. So, or we could have said 1 hour and 36 minutes. So I'll take that for the time. T represents the bus. So bus, this is all bus time. But I think it wants to know how the truck. So how long does it take the truck to overtake the tourist bus? So the truck is going to be t minus 2/5. So we would say 8/5, which is t minus 2/5, which gives us 6/5, which is 1 1/5 hour, or 1 hour, 12 minutes. Any of those, or 6/5 of an hour. I guess you can write that also. So that is going to be the truck's time. That's the bus time. It's going to travel for 1 hour and 12 minutes because it was 24 minutes later. So we had to subtract 24 minutes from 1 hour and 36, which is 1 hour and 12. It works. Exactly 20 minutes after Alex left home, his sister, Allison, set out to overtake him. Hey, everything doesn't have to be a competition. Alex drove at 48, nice, teaching kids how to speed. So, oh, here, get in the car and go chase after your sister. Right, nice. What's this book teaching you? What's the speed limit that they were driving? Are we in rural roads, or are we in the city? Alex drove at 48 miles per hour. Allison drove at 54 miles per hour. How long did it take Allison to overtake Alex? This is not a very good, this doesn't teach 8th graders how to be safe in driving. Alex, distance equals rate times time. Alex's distance, rate, Alex is 48 miles per hour. At least we're back into, not metric, but customary. Customary? units? There you go. Allison, hopefully they didn't get any car accidents while driving, while chasing. That's illegal, kids. Just, you know, I know you watch the movie where they're racing Fast and Furious. Thank you. See, that's not a very good TV show or movie to promote safe driving. 20 minutes again, we're in minutes here and we need to be in hours. So 20 minutes is equivalent to 1/3 of an hour. Woohoo! 1/3 of an hour, kids. So Alex left home first, so he gets T, and his sister is going to leave after, so we have to do T minus 1/3. When are their distances the same? So when does distance Alex equal distance Allison? Can we just call her Allie? Is that okay? 48T equals 54T minus 1/3. 48T equals 54T minus 118. Minus 18, I think that is. We're going to subtract 54T because we're going to get our variables on the same side. That leaves us with, don't subtract 54 from 48. You got to go 48 from 54. That's 6. So negative 6T equals negative 18 divided by negative 6. And you get T equals 3 hours. So that's how long Alex drove for, but not his sister. His sister left 20 minutes later. So this is Alex's time. And his sister is 20 minutes later. So can you subtract 20 minutes from 3 hours? Yeah, I can do that. 2 hours and 40 minutes. Because there are 60 minutes in an hour. I'm going to have to borrow. So you can do 2 hours and 40 minutes for Allie's time. Or you could have said 2 2/3 hours is also an acceptable answer. It doesn't say what format you need to give your answer. Oh, let's go back. Oh, it says how long. I was wondering if it was going to say what time. That's a tricky one. See, sometimes they ask you they give you the time. So that was a sort of a trick piece of information there. The McLeans. Are we talking John McClane? Like, again, California? John McClane, Officer McClane from Die Hard and the Nakamura Tower? Yeah, Die Hard, Christmas movie. McLeans drove from their house to Daytona, Florida, at 75 kilometers. When they returned, the traffic was heavier and they drove. Ooh, I like this. So this is the McLean house. The McLean house is here, and they drive to Daytona. Daytona Beach, Florida, spring break. So distance equals rate times time, and they're traveling at 75 kilometers per hour. They return the traffic, and they're returning from Daytona Beach to the McLean house. What do we notice about the distance? It's the same, yes. From the McLean house to Daytona is going to be the same as Daytona to the McLean house. And when they went home, their distance, rate, time, their rate of speed, it was way, way more trafficy. So 50. If it took them an hour longer to return, so we know time is going to be T, and time going home is going to be T plus 1 because it took an hour longer. But what do we know about the distances? They're going to be the same. So DM to D, McLean to Daytona, is going to be the same as the distance from Daytona to McLean. So distance is still going to equal distance, and we're going to set each one. So we have 75T equals 50 times the quantity T plus 1. 75t equals 50t plus 50. Let's move those t's to the same side. You get 25t equals 50. Divide by 25. And we get t equals 2. Remember, we have to understand which t is it associated with. T is to Daytona Beach. That's the way there. T on the way home would be t plus 1. So the question says, how long did it take him to drive home? This is time to Daytona. And so we have to add 1. So it took them 3 hours to go home from Daytona. Don't be afraid to write a lot in your answer. All right, it takes a plane 1 hour less to fly from San Diego to New Orleans. Notice how you say it, not New Orleans. Hey, let's go to New Orleans. No, it's called New Orleans. At 600 kilometers per hour than it does to return at 450 kilometers per hour. Well, yeah, if you travel faster, it will take less time. How far apart are the cities? What do you mean, how far apart is the cities? How far apart are the cities from San Diego to New Orleans? Google Maps. New Orleans, New Orleans, directions to San Diego. Well, I can just go on Google Maps and find out. Let's see if it'll give me a flying option. A flying option. If I was going to drive, it is 1,816 miles. If I was going to fly, that's miles, by the way, not kilometers. Flying, what? Give me a distance. I have to fly for 3 hours. Planes typically travel around 500 miles per hour. Or you can just go Google, how many miles by plane is San Diego to New Orleans? 1,599 miles. So let's see. Oh, and then, sorry. Then, I know you're trying to get done with this video. I'm not helping the process. So 1,599 miles is how many kilometers? 2,573. Let's see if it works. Oh, wouldn't that be so awesome if it did work? Oh yeah, hey, look how fast planes travel. Oh no, that's 600 kilometers. All right, so, oh Lord. So we've got San Diego over here on the west coast, and we're going to New Orleans in the southeast. And so, plane 1, this is P1, is distance equals rate times time. The rate of speed is 600 kilometers per hour. It takes it takes a plane, sorry. It takes a plane 1 hour less to fly. So that's going to be t minus 1 for plane at 600 than it does to return. So, return. Okay, so returning back, we'll call trip 2, going this direction, is going to be 600 equals 450t, because it's going to be less time going faster. So it's the same distance. So we have 600 t minus 1 equals 450t. 600t minus 600 equals 450t. Let's subtract the 600t, subtract the 600t, which gives us negative 600 equals negative 150t. Divide by negative 150. Divide by negative 150. Be good. 600 divided by 154 equals 4 equals t. So t Is that the fast way or the long way? That's the long way. So T is the long way home. Take the long way home. You know who sang that song? Supertramp. How far apart are the cities? So notice, they don't care about the time. They want to know the distance. So trick question, find the distance. So we can use either equation. This is the distance from San Diego to New Orleans, and this is the distance from New Orleans to San Diego. So you can use either one. I'm going to use D equals 450 times T, because less things to calculate. 450 times 4, and we get 1,800 kilometers is the distance. What did we say the kilometers was? Okay, it's 100 off, 101 off. I guess that's kind of close. Well, so the distance from San Diego to New Orleans using that flight path, maybe they had to go over mountains, is 1,800 kilometers. And that's it, kids. We're done with 4.8. Those are really, really important. You also have problems later on where people start in different places and they will go towards each other. So you have 3 different situations. So you have person A, person B, and then when will they be? So it's still distance, rate. Distance equals rate times time. In this situation, you're going to add the 2 distances to get the total distance. That's situation 1. Situation 2 we saw where they both are going in the same direction. And that's going to be, when are the distances, when are they going to catch up? That means one of the distances is going to be the same. Distance equals rate times time. Distance equals rate times time. So that's that situation. And then the third one, well, the first one we saw was when they left from the same place in opposite directions. This is still distance equals rate times time, distance, rate times time, and this is that total distance, total. So we're going to add those 2 distances. This is setting the distances equal to each other. This is adding the distance to get the total. So be aware of that. Pretty straightforward, pretty easy. You can apply it to every single problem, and it was relatively simple. Good luck.